Hi fixers, and today we're back with an Amstrad GX4000 console again. And no, it's not this one, although I do have plans for this, including an ultrasonic bath. No, it's this one. This working console has been loaned to me and it's going to be helpful for taking readings for comparisons to the torched board. But before all that, I did ask myself, do I really want to go to all the hassle of cleaning and restoring this burnt console just to play burning rubber? Well, no, not really. So today we're going to be making some pirate carts. Not a multi-cart, but actual titles in actual standalone 3D printed cases with a custom label that we're going to make together from scratch. And we're going to do it right now.
Mark fixes stuff. This video is sponsored by PCBWay. You can get an instant quote on a variety of services, or browse a library of talented makers' designs, add them to your cart, and have them delivered directly to your door. Back in 1990, Alan Sugar's Amstrad released the GX4000 console in Europe. At a launch price of £99, it could have done well, but the hardware inside was a repackaging of the Amstrad CPC Plus hardware. It's product refresh of the aging CPC line. And this presented a problem because with the Amiga already out in the market and the Mega Drive on the horizon, customer interest was low and the console was a flop. As a direct result of these poor sales, only 30 games were released on the system, with many planned titles being cancelled. Because the console didn't sell well, the carts didn't sell well either, so some of them can be pretty rare. This makes them expensive, so we're going to make our own. I found this board on the cpcwiki.eu forum. The PCB was created by Chinnery. He was kind enough to release the files there. I uploaded the Gerber files he produced to PCBWay and they made some boards for me, so big thanks to PCBWay. It's quite difficult to show on camera, but the cart contact edges are slightly beveled to enable easy insertion into the console slot. So in addition to the board, we are going to need an EPROM of the appropriate size for the file that we'll be burning to it. Luckily I've got a few. It can be quite hard to pick up EPROMs these days, so when I see them on sale I grab them. Official games released for the GX4000 will fit into the smallest size, the 27C1001, which is 1 megabit, and that's equal to 128 kilobytes. Some of the unofficial games, like the 2018 port of Ghosts and Goblins, are 256 kilobytes, so need a 2 megabit 27C2001 EPROM. And some ported titles like 2022's Blinky's Scary School need the whopping 512K capacity of the 4 megabit 27C4001 EPROM. Aside from the EPROMs themselves, we'll need a couple of passive components. We need 2 of these 4.7 kilo ohm resistors.
The board doesn't carry much current, so these are just some quarter-watt parts. The PCB is marked for 100 nanofarad capacitors, and that value is correct. But for through-hole parts like these, it's more commonly expressed as 0.1 microfarads. The marking you're looking for in any event is 104. This is just a cheap multi-assortment of capacitors, but these will be fine. Now there are two options for building this board. Let's quickly explore what those options are. One option is to scavenge an original copy protection chip from a real cartridge and solder it here. The ACID or Amstrad cartridge identification device was intended to tell the console or CPC Plus computer if the cartridge was genuine. This wasn't to stop piracy, because making a cartridge at home was beyond the means of most users in 1990. It was more an attempt to control software that could be released on the GX4000, much like the sharp practices that Nintendo had employed with the Nintendo Entertainment System. This level of control was probably an attractive proposition for Alan Sugar, because he really liked money. We can see here inside a genuine cartridge there's only an EPROM, but if all is not well with this copy protection circuit, it scrambles the data that comes from the EPROM, rendering the cartridge useless. If you're going to install an original ACID chip, you only need to solder one capacitor. But with real cartridges becoming finite and quite expensive, that's not really a sustainable option. Burning rubber. But some incredibly clever people have discovered a way around this. You see, there's a flaw in the design of the ACID chip. The console or computer signals that the response from the ACID is incorrect for a long enough period of time that the response can be flipped, making the host machine happy. And that's where this chip comes in. This is a 74112 chip, a piece of 74 series logic, a dual JK flip-flop, and it flips the input to the console or computer, satisfying the host machine that the cartridge is actually genuine. For our tip-top flip-flop hack, we will need to populate all of the passives in the PCB, so let's get to work. There's no room for sockets on these boards, it makes the chips stand too high. So we'll need to be brave and solder the chips directly into the board. We'll use a touch of Smurf exhaust to hold the package in place. And some lovely flux to let our solder flow. As a side note here, one thing I've learned when soldering on white PCBs is that the flux looks a lot messier. Of course, this makes it easier to clean because you know when you've cleaned it, but just something to bear in mind for your own project. Yes, I'm using leaded solder here, and the answer to your question is no. I'm 100% absolutely not sorry in the slightest. I do have to make a mental note not to eat it though. After soldering, I just quickly clean up the board with some isopropyl alcohol and a cotton bud. I think that's clean enough. With our soldering completed, we can flip the board around and remove the blue poo. Excellent, our logic is installed. Next up we can install our ceramic 104 capacitors. We'll just pop them into the board and splay the legs underneath to stop them dropping out when we flip the board over for soldering. Of course, we'll add a dab of flux. Ceramic capacitors like these are non-polar, so there's no right or wrong way around. You can't put them in the wrong orientation. That being said, I'd like to have the numbers facing in the right direction, although I've noticed these two ceramic capacitors are slightly different. Annoying. Time for the snip. Oh, no problem. Now the 4.7K resistors. Chinnery's design is excellent, so it makes it really easy to know which components go where. This is a small tool that I 3D printed a couple of years ago. It's really handy for getting nice sharp bends in the resistor leads. Oh, I do like that. It makes insertion easier, but it also looks nicer, I think. Again, I like the resistor bands to run in the same direction on each part. I'm still a bit annoyed by those two capacitors though. And you guessed it, a bit more lovely flux. Using the flux really can make the soldering more reliable. And this soldering isn't my finest hour, I've got to admit. And with the leads being clipped, the passives and the logic are all installed. Hooray! Now we need to program our EPROM. As I said before, we can't use sockets. A socketed EPROM wouldn't fit inside a cartridge shell. But you can just about get a socketed EPROM into the console, on a slight angle. So here's one I built with a socket earlier. This is for testing the EPROMs I program without having to solder them into the board. We do need to do some file conversion before we burn that data to the EPROM, so I want to test that the EPROM is working in the console before I solder it into the board. And this will do in a pinch. The real acid test here, and no apologies for the pun, is if with the chip installed, it will still fit into the console slot. Let's give it a go. That's good enough for me. It's actually sitting on the case there, so not too bad. With that in mind, let's go over to the computer. Here we have some CPR files. .cpr seems to be the standard dumping format for CPC Plus cartridges. We need to convert these into a .bin format that can be loaded into our EPROM programmer. For this, we'll use a program called CPR Tools. It's very simple to use, as you can see, and we're going to kick off with Ghosts and Goblins. The CPR file shows us 257K, so I hope it's reduced to 256K for our bin file. Well, I suppose there's only one way to find out. And that has given us a 256K bin. A good start. That's the right size to fit into our EPROM, so let's put our EPROM into our EPROM programmer. Firing up the EPROM programming software, there's a couple of things we need to do. First of all, we need to select the EPROM type. With the correct EPROM type, or as they like to call it, device type selected, we next need to load the binary file into the buffer of the EPROM burning software. I like to have a scroll through to make sure it all looks okay, and here we can see some human readable text, so that's a good start. Upon hitting program, our EPROM is flashed with our game. For the sake of the video and in order to save you, the viewer's time, I sped this sequence up, but it took a little over 2 minutes. It's verified and it's programmed. Now we just need to test it. Our retro rewind EPROM straightener makes another guest appearance. It really is the gift that keeps on giving. With the legs straightened out, it's so much easier to get the device into the socket. I've got to say, this feels a bit ad hoc and slightly naughty. But let's see if it works. Please work. It turns out that I can't turn the console on because the flap at the back is blocking the on switch. But a bit of jiggery pokery helps us out. Hooray! And that's success as the cartridge boots first time. I really wasn't sure if this was going to work. So that EPROM is good, but what about a case? Well, here's one that I printed earlier. It's by Seawees, and I found it in the same thread as the PCB files on cpcwiki.eu. It's quite clever because it clips shut and doesn't need screwing or gluing. I won't clip it together now though because I might not be able to get it open again. I think that's going to be pretty good, but we will need a label. Okay, so I think what we'll do is we'll make a label that's based on the original, although we won't try to copy it. Using my digital calipers, I took some dimensions. I'm not going to list them here because they won't make much sense, but what I will do is I'll make a file and I'll share it with you on my website. Let's get Photoshop fired up and ready to rock and roll. We're going to make a custom document size called GX4000 label. I've added together all of the measurements that I took from the label on the original cart. First of all, a horizontal guide at 50%. And then some guides roughly where the label will fold around the top of the cartridge. I also added some guides where the edge of the red to white gradient will go to on the label. And by snapping to these guides, it means that we can get exactly the right size for our right to left red to white gradient. I'll try to make sure that I keep the layer names tidy so that people can make their own labels should they wish. Here goes nothing. And that's not too bad for a first attempt. You'll also notice that I've feathered the edges and put a radius so they have a slight rounding. Now there are some labels that look like this, but I thought we'd try and take the graphics off of the original cart, so I just took a picture with my phone. Now obviously if we put that onto the label and printed it, it would look pretty bad. So let's see if we can take that, manipulate it and tidy it up a bit. Yeah, not something that I'd want to print, to be honest. It's grungy and damaged looking, and also some of the titles that I want to reproduce weren't by Ocean at all. It does give us a good idea of how it will fit together though. Let's create a new document and see if we can clean up these graphics. I think the first thing to do is to put the brightness up overall. That should knock out some of the noise in the background, giving it a kind of a watermark feel. That looks like a good level. Next, I want to take out the background. In fact, I want to take out anything that isn't the watermark image. We'll use the background eraser tool for this. Photoshop actually has a one-click solution for this, which will take out the whole of the background in one go. But I like to do it manually with the background eraser tool so I can check my work as I go along. As we proceed, I'll take out any blips, dips or divots with the clone or healing tool. The biggest problem is this Ocean software copyright notice, so I'm going to remove it. Where it goes into the pattern, we'll paint that back in using the clone tool. This kind of reconstructive Photoshop work needs an eye where you can kind of see beyond the noise, see the shapes behind the shapes. And we're really zoomed in here. It's important not to take details to the nth degree because you'll end up becoming a pixel peeper. And that means that you'll spend a lot of time working on something which won't necessarily show up in the printed product. Switching to our clone stamp tool, we're going to the areas where we need to actually paint out the black of the text. I use the polygon selection tool to cut a shape and then just fill it with clone data. This kind of job is weird because it always looks terrible until it suddenly doesn't. That's a bit lumpy, but it's good enough for jazz. Okay, just reconstructing the tail of this shape now. Again, the polygonal selection tool comes into play, and I simply paint in the pattern from its opposite. What is that, a leg? I don't actually know. And there's a few more little divots and scuffs to clean up. And I missed a bit of the background as well. In Photoshop, the checkerboard that we can see in the background shows transparency, so I've put a white layer underneath to see if there's anything else that needs to be removed. And we can see that there's some artifacts around the edge of the document. I'm actually not too worried about these because we'll end up sizing this slightly larger than the label. But you know, whilst we're here. I just noticed that the corner's missing down here, so I think we'll copy that from over there. And as I said earlier, it's really easy to slip into pixel peeping territory. I think that's okay. I created this document the exact size that we'll need in our final label, so let's just drag the edges of our image so they're off the document. I'm not too worried about the ratio either. It's not a reproduction and just something that's meant to look better than a blank plain label. I'm also aware there's other patterns on other cartridges, but this is the one I've got, so this is the one I'm making. Pasting our work into our actual label, I think it's going to look pretty good. Let's turn off the nasty copy and see how it looks. And oh wow, I think that looks a lot better than anyone was expecting. It's not perfect by any means, but it kind of gives the impression of the original label. I'm fairly happy with that. Let's make sure that the layer's cloned and named properly, for anyone who might like to use this label in future. So I've named this layer front graphic, but there is a rear aspect to the label, so let's clone this front graphic layer and then go and use the transform tools to rotate it around. Now it's rotated, we can simply move it into position for the rear of the label. I think it's starting to come together. What do you think? Now because this isn't a reproduction, I think we can take a few liberties, and I think something that was always missing from these cartridges was some text on the spine. So we're going to add some. And yes, I know there's a typo, don't at me. I've edited this down for the sake of your sanity, but I did play around with fonts for a little while until I found something that I felt conveyed the actual original feel of the label.
You know, the funny thing is, I'm taking much more care over these labels than the originals ever seem to have spent on them. They really are a mismatch. And some of them have even got dot matrix over the top of blank labels. That looks really ugly and the text gets lost on the background, so to combat that, I'm putting some strokes on the layers with text in them. And I think this needs to be in capitals, don't you? But of course now it's too big. But that actually does look quite good. And our fake cart really does need the official trademark symbol. And we can copy and paste the layer style to take our stroke data across. I'm usually a bit faster in Photoshop, but I'm trying to work in a way that I can create a label that others can use and enjoy on their own creations. We can select both of these text items and scale them down together. I think that's about right. I'll make some groups for the layers that represent the front, the back and the spine. I'm keen for anybody who comes after me to know exactly what's what and be able to edit them easily if they wish. Now with our layers grouped, we can turn on and off all the elements individually, or we can drill into the folders and edit those items on their own. To save myself some work, I've cloned the Ghosts and Goblins from the front, and I'll simply resize the text so that we can put some copyright information on the back. Even though my cartridge is a bit yo-ho-ho, I want to credit Capcom for their original work in 1985. And then of course it's only fair to mention the conversion was by Zephos and Targan in 2018. There's only one thing missing from this. It's upside down, and it'd be really nice if we could add a little copyright symbol. Lovely. And with that, our label is done, but it would be unwise to try and print from this document. It's always best to create a document the size of your physical output media. Then you can paste your items in and control where they are in the layout. With my new document ready, in the original document I go Ctrl A to select the whole document, Ctrl Shift C to select all layers, and then I paste it into my A4 sheet. If I wanted multiple copies of the same label I could paste multiple times. But I don't, so I've gone off and created some variants of the label for all of the EPROMs that I intend to burn. And by going into landscape I've found that I can fit 10 labels on each sheet of A4 paper. Which is quite economical really. When it comes to printing, I've selected that Photoshop will manage the colours using a printer profile for premium semi-gloss photo paper and a rendering tint of relative colorimetric. I'll make sure that borderless is off because that will actually scale our image down, and I hit print. Exciting times as we wait for the output from the printer. Let's go over to the printer and see how we're getting on. Not too bad. They're not going to fool a collector, but they're certainly better than no label at all. In fact, they're better than some of the original labels. I'm quite pleased with these. Okay, time to solder the EPROM into the board. You've seen enough soldering for now, so let's do this really quickly. I've not sped up the video at all here, it's just my natural skills, honest. And with that, the board is complete.
Now we can finally house it inside the cartridge case that I 3D printed earlier. There's a handy little locating lug. Then we take the top half of the shell and pop it onto the bottom. With a little push, the lugs start to clip into place. There, not too bad at all. And now we get to place on the sticker. I'm really excited to do this. Heads up, it took me about 5 minutes to get this started, so I've cut that bit out. I thought that maybe locating it on the spine correctly first would be the best idea, but I have actually got a few little bubbles and ridges in the label. I suppose I could always print another one. I think that's okay. The back's okay as well. Time to test. Placing it in the slot and powering on. Ghosts and Goblins springs to life on the screen, which is no surprise because we'd already tested it. I played Ghosts and Goblins for probably about an hour. It's a really good version, and if you'd got this back in the day, well, you wouldn't have had any complaints considering this is an 8-bit machine. Gameplay's familiar. It's frustrating and at some points it's really difficult. That being said, it's fair, so if you do die, you feel like you deserved it. And of course, true to form, there's lots of running around in your pants. I managed to get past the first level, but I don't think I could get past much more than that. The graphics really changed nicely in the second level. I was really impressed. I also played Switchblade, which I was told was one of the better titles for the system. And the price on eBay reflects that. It certainly has a unique visual look, but I must admit, I didn't really know what the hell was going on, so I switched to Blinky's Scary School. Well, that's the end. Another pointless exercise. Thank you so much for watching. Here's my patrons on the screen. They're pretty amazing. You could be amazing too and join them at patreon.com/MarkFixesStuff. You'll get ad-free early access to my videos, access to the exclusive Discord channel, and, well, I don't know, the really, really nice feeling of helping me keep the lights on and make more videos like these. Thanks so much for everyone who's watched and given their support. I really do appreciate it, and I'll see you in the next video. Bye.